In the last video, I discussed about static route and default static route. Now we are going to look into the implementation part of this. So first of all, these IP addresses are already configured. So 192.168.1.2 is configured. So if you look at here, we have 1.2, 1.1. The IP addresses are already configured. Now, if we are sending a packet from here to here, if you look at here, it is successful. Let me send a packet from here to here. It has failed. Okay, that's not a problem. If it has failed, it is successful. Whenever you send packets, like first 1 or 2 packets could fail, because if you know about the MAC address table, like it takes time to build the MAC address table or the ARP table, you send broadcast, and how the mechanism works. The same thing with the routing table as well. If first 1-2 packet fails, it's completely fine. Sending packet from here to here, and also sometimes if we are throwing packet like this way, it could be an interface related issues as well, because this router has got many interfaces. Successful. Overall, you could send packets from here to here, here to here, here to here, here to here. However, sending a packet from here to here is failed. Okay. Now I will describe briefly why we. Let's come here. If you look at here very carefully, let me take this one. This is in the same network, and these interfaces are in the same network. These interfaces are in the same network. So if you are sending a packet from here to here, it will be successful, no problem. If you are sending a packet from here to here, it will be successful, no problem. If you are sending a packet from here to here, it will be successful, no problems. The only problem happens when you are trying to send a packet from here to here, because they are not in the same network. They are not in the same network, and that is why you need a routing protocol. When this is the destination, R1 is the destination, when R1 is the destination, you are going to send packet to 192.168. So you are going to send packet to 192.168 2.0, which is 2.0. Then the subnet mask of it, and also this is going to be your next hop. For R1, we don't have any left hand side, so always your next hop will be the router, which is R2, and which is always this interface gigabit 0/0. So you could have right here gigabit 0/0 of R1, because you might get confused. R2 also has gigabit 0/0. So when you are writing here the exit interface will be your personal exit interface, not your next hop's exit interface. Okay. If you think logically, your next hop is not exit interface. Your next hop is your entry interface. You are exiting the packet to send to somewhere. So you are having the exit interface. Now, when we are R2, I already mentioned in R2, you will be sending packets to this network and this network, which means this is the network and the other network is here. You are not sending packet to this network or to this network. When we are using R2, you are sending packet to this network and this network. These networks are already directly connected. So you don't have to mention about them. So you will have two statements, and we do have here two statements. Sorry. Sending a packet to this network and to this network. And the exit and the next hop IP address will change when you are sending to this network 192. Of course, you are going to use R1 as an exit interface. Sorry, it is 172. So when you are sending packet to this network, then your R3 is the exit interface. When you are sending packet to this network, your R1 has the exit interface. For R3, again the same thing. You are sending packet to this network. You are sending packet to this network. And obviously, you need to know about this network as well, because without knowing this network, you won't be able to send packet here. As for this network and this network, they're directly connected to R3, so you don't have to mention. So you will be sending packets to 3 networks. For R3, it doesn't have anything on the right hand side, so everything goes to the left. And since everything goes to the left, your next hop IP address will always be this one. R2's this interface. And that is why if you look at here, we always have the same thing. Now let me put this configuration. For R1, let me put the configuration for R2. Enable. Let me put the configuration for R3. Once we have put all the configuration, we will be able to send packet. Now, firstly, if you come here, you need to check the routing table. Show IP route is the command to check the routing table, but we are in the global configuration mode. So we will come back here, show IP route. If you have any entries here, these are the locations where you can send packet. For example, if you look at here, I can send packet to 2.0.0 network via 1.1.2. So where is 1.1.2? So there is 1.1.2. I can send packet to 172.16 via 1.1.2. So I will be sending the packet to 1.1.2. I will be sending packet to this location, to this location. Of course, these locations, they should know how to send the packet to 2.network and to 172.16.network. If these locations, which is going to be R2, doesn't know, then your packet cannot reach there. But for you only, you can send packet to these 2 locations. Now, if you look at here very carefully, 192.168.1.0, so this is directly connected. So one network is directly connected. So if you look at this router, he is directly connected. Then if you look at this network, this is directly connected. They are directly connected. So once you are directly connected, you know about them. Now these are the networks where you are connected statically with static routing. So if you look at here, these are the static. Make sure to come and check your static route. Now if you see this one, then that is your default static. Okay. Of course, in BGP we have these things, but they have different meanings. But you will see something like S static, so you know that that is static. You can go and check all the routing tables. You will find the same thing. Let's send a packet from here to here. As I said, first packets may fail, but after that it should be fine. See, successful. Let's send another packet from here to here. Failed. Let's send again. Failed. Successful. Now, if you configure only one router, and if you, let's say you configured R1 correctly, but you made a mistake with R3, you will not get the success result, because every packet that you send, you will get a reply based on that, right? So you may not get the success result. So all the routers have to be configured properly. This is one of the problems with the static route. If one of the routers along the way is broken, then maybe nothing works. So that is why we need to be careful. I will show you the implementation of the default as well. So how do I show you the implementation of the default? Let's say, for example, if you don't know anything, let's say any network, then where are you gonna send, or to whom you gonna send? So how do you configure that one? Let's say, for example, R2 is our cloud, or R2 is the ISP. And how do I configure? Default for R2. Come here, config terminal, IP route. This is simple. Like I want to mention everything, so it will be 0.0.0.0. It will always be the same. 0.0.0.0. And what's the next hop's IP address? The next hop's IP address, or your exit interface, the next hop IP address is 1.1.1.2. So if you do here 1.1.1.2, that's it. If you are doing the floating static route, so if you look at here, you can put the AD values, which is not we are putting at this point in time. So we'll keep it like this. And if you want to see the routing table, I can put here do show IP route. So why I'm putting here do? Because I'm using show command in the global configuration mode. Come here. If you look at here, we have this one. You see here. So anything is static asterisk default. So you see here candidate default. So if you don't know about anything, you can use this one, like 000, anything, any destination via 1.1.2. So you will be sending the packets to 1.1.1.2. So the 1.1.2, 1.1.1.2 takes the responsibility of sending the packet to your destination. It is his responsibility to send your packet to this destination. Okay. Now that is default static. Let's say if you made a mistake with any of them, and if you want to make some changes, how do you do that? It's very simple. I will remove the default static. How do I remove the default static? You write the same statement, but append no and press enter. Now if you look at here, show IP route, that is removed. It is true for the static route as well. If you made a mistake with the command or something, you can go and you can just remove that one. Show run, sorry, do show run. So you will be able to see all the commands that you have done with IP route. It will be here. So if you made a mistake, or what commands you have given in the past you don't know, you can always come here and you can always see what are the commands that you have given, and you can remove the commands from there as well. So be aware of the mistakes. Some checking mechanism that I said for the routing. Check the routing table, whether the routing entries are there or not. Check in the configuration whether you have done some mistakes or not. First few packets may fail. That's completely fine, but eventually it will be successful. So if you send 4 packets and you still get fail, you know that means you made a mistake somewhere. You know that you made a mistake somewhere. And read these things and you will be able to understand which network is connected through which protocol. For a static route, your whole configuration needs to be correct. Otherwise, it may not work, depending on the topology that we are talking about.